Right now, humanity is listening to a machine that should already be dead. A spacecraft launched before the internet, before personal computers, before most people watching this video were even born, is still whispering to Earth from interstellar space. And the signal takes nearly 24 hours to arrive. Voyager 1 is now so far from Earth that sunlight no longer feels like sunlight. Our sun, the star that fills our entire sky, warms our planet, and gave birth to every living thing you have ever known, has shrunk into just another bright point in the darkness. A distant star in Voyager's rearview mirror. And somehow, after nearly half a century, it's still moving, still transmitting, still surviving. But Voyager was never supposed to last this long. When NASA launched the spacecraft in 1977, the mission was expected to survive only a few years. Visit Jupiter, visit Saturn, send back photographs. End of story. Nobody imagined that 47 years later, Voyager would become the most distant object humanity has ever created, or that the engineers who built it would grow old trying to keep it alive. Today, Voyager 1 is nearly 25 billion kilometers away from Earth. So far away that every command NASA sends takes almost an entire day to arrive. A 2-day conversation across interstellar space. And recently, something went wrong. In 2023, Voyager suddenly began sending corrupted data back to Earth. Not silence, something stranger. Messages that made absolutely no sense. Engineers at NASA stared at screens filled with unreadable symbols, trying to understand whether humanity's farthest explorer was finally dying. What happened next was almost impossible. A group of aging engineers, many of whom helped build Voyager decades ago, managed to diagnose the problem from 24 billion kilometers away. The issue turned out to be a failed memory chip inside a spacecraft older than the internet, older than modern computers, older than most people watching this video. And somehow, they fixed it. They sent a software patch across interstellar space, waited nearly 2 days for a response, and Voyager spoke again. But this story isn't really about a spacecraft. It's about something much bigger. Because Voyager 1 has become more than a machine. It is humanity's most distant memory. A tiny artificial object drifting through infinite darkness, carrying a golden record filled with the sounds of Earth. Human voices, music, laughter, the sound of ocean waves. A message for civilizations that may never exist. And one day, long after humanity disappears, Voyager may still be out there, silent, cold, still drifting between the stars, carrying proof that on one small world, a species once looked up at the universe and tried to reach beyond itself. In 1977, NASA launched 2 spacecraft into space within just a few weeks of each other. Voyager 2 first, then Voyager 1. And despite the names, Voyager 1 was actually launched second, because NASA realized something unusual. If Voyager 1 took a faster trajectory, it could reach Jupiter and Saturn earlier than its twin. So the spacecraft designed to arrive first became Voyager 1. At the time, nobody thought these missions would become legendary. The objective seemed relatively simple. Fly past Jupiter, fly past Saturn, take photographs, collect scientific data. Then eventually, the mission would end. That was it. 4 years. Maybe a little longer if things went well. Nobody imagined these machines would still be alive nearly half a century later. Because Voyager wasn't built during the modern computer age. It was designed before the internet existed, before smartphones, before laptops, before most homes even had personal computers. The onboard memory was smaller than a modern digital watch. Its processors were unbelievably primitive by today's standards. And yet, this ancient machine would eventually travel farther than anything humanity has ever created. But Voyager's journey was only possible because of something incredibly rare. A cosmic accident that happens just once every 176 years. In the late 1970s, the outer planets aligned in a way that allowed a spacecraft to visit multiple worlds using gravity alone. Jupiter, Saturn, Uranus, Neptune. Normally, reaching all 4 planets would require enormous amounts of fuel and multiple missions. But during this brief alignment, NASA realized a single spacecraft could use each planet's gravity like a slingshot, accelerating deeper into space with every encounter. It became known as the Grand Tour, one of the most ambitious planetary missions ever attempted. And the scale of the challenge was almost absurd. At the time, humanity had never visited the outer planets up close. Jupiter was still a blurry world hidden behind clouds.
Saturn's moons were mysterious points of light. Nobody knew what waited out there. Voyager was being sent into regions of space humanity had never truly seen before. And there was another problem. The spacecraft had to survive for years in deep space, with no possibility of repair, no rescue mission, no second chance. Once Voyager left Earth, it was completely alone. So NASA engineers became obsessed with redundancy, backup systems, backup computers, backup thrusters, duplicate communication hardware. The spacecraft was over-engineered in ways that now seem almost unbelievable. And according to several Voyager engineers, some of them quietly filled the fuel tanks with more propellant than the mission officially required, because deep down, they suspected Voyager might go farther than anyone was willing to publicly admit. They were right. Much later, Voyager would become the first human-made object to leave the protective bubble of the solar system entirely, the first machine in history to enter interstellar space. But before any of that happened, Voyager had to survive its first destination, Jupiter, and what it found there changed space science forever.
When Voyager 1 reached Jupiter in 1979, NASA realized something almost immediately. The solar system was far stranger than humanity imagined. Because until that moment, Jupiter had never really been a place, just a distant object in the sky, a giant blurry planet hidden behind telescope glass. But then Voyager arrived, and suddenly, the unknown became real. The first images shocked scientists. Jupiter's atmosphere looked violent, almost alive. Storms larger than Earth twisting through the clouds, jet streams moving at incredible speeds, lightning eruptions deep beneath the atmosphere, and at the center of it all, the Great Red Spot, a storm so massive, our entire planet could fit inside it. But Jupiter itself wasn't the biggest discovery. Its moons were. One of them, Io, appeared completely impossible. Voyager captured giant plumes erupting from the surface. At first, scientists thought there was something wrong with the cameras, because moons weren't supposed to behave like this. Small worlds were expected to be cold, dead, geologically inactive. But Io wasn't dead at all. It was erupting with volcanoes, hundreds of them. Voyager had discovered the most volcanically active world in the solar system, an entire moon being torn apart by Jupiter's gravity. Every orbit, the giant planet stretched and squeezed Io from the inside. The friction generated enormous heat beneath the surface, enough to melt rock, enough to create underground oceans of magma. Humanity had never seen anything like it before, and suddenly, the universe became stranger. Then Voyager looked at another moon, Europa, a frozen world covered in ice. At first glance, it seemed empty. But scientists began noticing something unusual about the surface. Cracks, movement, patterns that suggested the ice might be floating on something beneath it, an ocean, a massive hidden ocean trapped below the surface, possibly containing more water than all of Earth combined. And that idea changed space science forever, because for the first time, serious scientists began wondering if life in the universe might exist in places humanity never expected. Not on Earth like planets, but beneath frozen alien oceans orbiting giant worlds in deep space. This is what Voyager kept doing everywhere it went. Destroying assumptions, turning distant lights into real worlds, places with storms, volcanoes, chemistry, mysteries. And suddenly, the mission that was supposed to last only a few years was becoming one of the greatest journeys in human history. But Voyager was still moving outward, still accelerating deeper into the darkness. And ahead of it waited Saturn. By the time Voyager left Jupiter, the mission was already considered a success. Everything after that was a bonus. But ahead of the spacecraft, another world was waiting, Saturn. The planet humanity had dreamed about for centuries, and Voyager was about to reveal it in a way nobody had ever seen before. When the first close-up images arrived, they looked unreal. A giant golden world suspended in black space, surrounded by rings so enormous they stretched across hundreds of thousands of kilometers. From Earth, Saturn's rings looked smooth, simple, almost flat. But Voyager revealed something completely different. Thousands upon thousands of individual ring structures, thin bands, gaps, braided patterns, entire sections shaped by invisible gravitational forces. The rings weren't solid at all. They were made of countless fragments of ice and rock, all orbiting Saturn together like cosmic debris trapped in permanent motion. And then Voyager discovered something even stranger. Some of Saturn's moons were actually shaping the rings themselves, tiny moons hidden inside the ring system.
Using gravity to carve gaps and patterns into the ice, scientists started calling them shepherd moons because they were literally guiding the rings through space. But Saturn had another secret: Titan, its largest moon. At first, Titan looked disappointing. Voyager's cameras couldn't see the surface. The entire world was hidden beneath a thick orange atmosphere. But that was exactly what shocked scientists, because Titan was the first moon humanity had ever seen with a dense atmosphere, an entire alien world wrapped in thick clouds. And decades later, scientists would eventually discover rivers, rain, lakes, and weather systems there. Not made of water, but liquid methane, an entire world where it rains natural gas from the sky. Everywhere Voyager traveled, the universe kept becoming more complicated, more alive, more alien. The spacecraft that was supposed to take a few photographs was completely transforming humanity's understanding of the solar system. And then, the mission should have ended. But it didn't. After Saturn, Voyager 1 turned upward, out of the flat plane of the solar system, away from the planets, away from the sun, beginning a journey no spacecraft had ever attempted before, toward interstellar space, toward the darkness between stars. As Voyager moved farther away, the sun slowly started shrinking behind it. Earth disappeared into invisibility. The planets became tiny points of light. And eventually, Voyager crossed into a region humanity had never explored before. The edge of the sun's influence itself. What Voyager discovered there was something nobody expected, because the space between stars was not empty at all.
Voyager 1 was now traveling farther than any human object in history, far beyond the planets, far beyond Pluto, far beyond the edge of the known solar system. And eventually, it reached something scientists had waited decades to see: the boundary between our solar system and interstellar space. For billions of years, the sun has been creating a giant protective bubble around the solar system, a region dominated by solar wind. Charged particles constantly flowing outward from the sun at incredible speeds. This invisible bubble is called the heliosphere, and everything humanity has ever known exists inside it. Every planet, every asteroid, every human being in history, protected inside a magnetic cocoon created by our star. But eventually, that bubble ends, and in 2012, Voyager 1 crossed it, becoming the first object ever created by humanity to enter interstellar space, the first machine to leave the sun behind. But what Voyager discovered there made almost no sense. Scientists expected interstellar space to feel empty, cold, silent. Instead, Voyager detected something astonishing. The temperature beyond the heliosphere appeared to reach tens of thousands of degrees, in some measurements, hotter than the surface of the sun itself. And yet, Voyager survived, completely unharmed. At first, this sounded impossible. How could a spacecraft pass through temperatures hotter than the sun without melting? The answer revealed something deeply strange about the universe, because temperature in space doesn't behave the way humans experience it on Earth. The particles in interstellar space carry enormous energy, but there are almost none of them. The region is so unbelievably empty that despite the extreme temperatures, almost no heat transfers into the spacecraft itself. Voyager was flying through a wall of fire, inside near total emptiness. And then Voyager discovered something even stranger. Interstellar space was not silent. The spacecraft detected a faint vibration moving through the plasma between stars, a constant hum echoing through deep space itself. Humanity had never heard anything like it before, because until Voyager crossed the heliopause, nobody even knew it existed. But perhaps the strangest discovery involved magnetic fields. Scientists predicted the magnetic field beyond the solar system would shift dramatically once Voyager crossed the boundary. It didn't. The magnetic field outside the heliosphere appeared strangely aligned with the one inside it, completely contradicting expectations. Even today, scientists still don't fully understand why. This is what made Voyager extraordinary. The farther it traveled, the stranger the universe became. A mission designed to study planets was now rewriting humanity's understanding of interstellar space itself. But while Voyager was discovering things nobody expected, another problem was quietly beginning back on Earth. Because after nearly half a century of survival, the spacecraft itself was starting to fail. In 2023, something inside Voyager 1 started going wrong. Not an explosion, not total silence, something far more disturbing. The spacecraft was still talking to Earth, but the messages suddenly stopped making sense. NASA engineers began receiving streams of unreadable data, Broken telemetry, corrupted signals, meaningless patterns. Voyager was clearly alive, but nobody could understand what it was trying to say. And that made the situation terrifying, because Voyager 1 was now nearly 25 billion kilometers away from Earth, the farthest human-made object in existence. No astronaut could repair it. No rescue mission could reach it. Everything depended on commands traveling across almost an entire light day of space. At that distance, even simple communication becomes painfully slow. A command from Earth takes nearly 24 hours to arrive, then another 24 hours for the response to come back. Every attempt to diagnose the problem required waiting almost 2 full days. And meanwhile, Voyager kept drifting deeper into interstellar darkness. The spacecraft itself was ancient. Its computer systems were designed in the early 1970s, before modern software engineering, before the internet, before most of today's engineers were even born. Some of the original documentation still existed only on paper, and somehow, NASA now had to debug a dying spacecraft older than modern computing itself, from across the solar system. What made the situation even stranger was who stepped in to help. Many of the people who understood Voyager best were now elderly. Some had spent decades working on the mission. Others had helped build parts of the spacecraft itself. The machine was aging, and so were the humans trying to save it. Then engineers finally traced the problem to something unbelievably small, a failed memory chip inside the flight data system, one corrupted component, inside a spacecraft that had survived nearly half a century in deep space. And now came the impossible part, fixing it remotely. NASA engineers developed a software workaround, a patch designed to move Voyager's damaged code into a different section of memory. But there was no guarantee it would work. If the command failed, humanity could permanently lose contact with the most distant object it had ever created. And once the transmission was sent, there was nothing left to do but wait. Nearly 2 days of silence. Then finally, Voyager answered. The spacecraft began sending back readable data again. Against all probability, the repair had worked. A group of aging engineers had successfully repaired a dying spacecraft from 24 billion kilometers away. One of the most distant technical repairs in human history. But even after the fix, everyone at NASA understood something difficult. Voyager had survived, but it was still dying, because the real threat was no longer software. It was time itself. By the time Voyager's systems began failing, the people who built the spacecraft had grown old alongside it. Some of them had spent nearly their entire lives working on the mission, and somehow, after almost half a century, they were still trying to keep it alive. Linda Spilker joined the Voyager mission in 1977, her very first job out of college. At the time, Voyager was supposed to be a short planetary mission, a few years exploring Jupiter and Saturn. Nobody imagined it would still be operating decades later, or that an entire generation of engineers would spend their lives connected to a machine slowly disappearing into interstellar space. And that's what makes Voyager different from almost every other mission NASA has ever launched. The spacecraft didn't just survive longer than expected, it survived long enough to become personal. For decades, these engineers woke up every morning knowing Voyager was still out there, still talking, still sending data back across billions of kilometers. The spacecraft became part of their lives, a companion drifting through the darkness. And now, one by one, they were being forced to shut parts of it down forever, because Voyager's power source was dying, slowly, inevitably. The spacecraft runs on something called an RTG, a radioisotope thermoelectric generator, essentially a nuclear battery powered by decaying plutonium. At launch in 1977, Voyager generated enough electricity to run all of its scientific instruments comfortably. But every year, the power drops slightly, just a few watts at a time, small enough to seem insignificant, until decades pass. Now, Voyager produces less than half the power it once had, and NASA engineers are running out of things to turn off. First, the cameras went dark, then additional instruments, then backup systems, each shut down permanent, each command silencing another part of the spacecraft forever. And for many scientists, those instruments represented entire careers. Hardware they designed in the 1970s, still transmitting data nearly 50 years later. One scientist described shutting his instrument down like losing a best friend, because for half a century, it had always been there, always sending something back, and then suddenly, silence. This is the strange tragedy of Voyager. Not a dramatic disaster, not an explosion,
just a slow, fading voice disappearing into the universe, a machine surviving longer than anyone expected, while the humans who built it slowly disappear too. And yet, even now, NASA engineers are still trying to buy Voyager more time. A few extra months, a few extra years, anything. Because once Voyager finally goes silent, humanity may lose its only direct connection to interstellar space itself. And the end is getting closer.
In 1990, Voyager 1 was preparing to leave the solar system forever. Its primary mission was over. The giant planets were behind it, and NASA was getting ready to shut the spacecraft's cameras down permanently to save what little power remained for the long journey ahead. But before that happened, one scientist made a final request. Carl Sagan wanted Voyager to turn around. At the time, the spacecraft was already nearly 6 billion kilometers from Earth, and pointing the cameras back toward the sun carried risks. The bright sunlight could damage the instruments. Some NASA engineers thought the image wasn't worth it. After all, from that distance, Earth would barely be visible at all. But Sagan kept pushing, because he believed humanity needed to see itself from that perspective at least once. Eventually, NASA agreed. Voyager turned its cameras back toward home and captured one of the most important photographs in human history. At first, the image almost looked empty, just darkness, a scattered beam of sunlight crossing the frame, and hidden inside that beam, a tiny pale speck, less than a single pixel wide, Earth. Every human being who had ever lived existed inside that tiny point of light. Every empire, every war, every religion, every dream, every person you have ever known, contained within a fraction of a pixel suspended in cosmic darkness. For the first time, humanity saw itself from the outside, not as nations, not as civilizations, but as something incredibly small, fragile, temporary. Later, Carl Sagan wrote words that would become immortal. "Look again at that dot. That's here. That's home. That's us." The image became known as the pale blue dot, and it changed the way millions of people thought about humanity's place in the universe. Because Voyager revealed something deeply uncomfortable. The universe does not feel designed around us. Earth is not the center of anything. From interstellar distance, our entire civilization becomes almost invisible. And maybe that's what makes the photograph so powerful. Not because it makes humanity feel meaningless, but because it makes life feel rare, precious. A tiny world filled with consciousness, drifting through overwhelming darkness. After taking the photograph, Voyager's cameras were shut down forever. The spacecraft would never look at Earth again. And as it continued drifting deeper into interstellar space, it carried something else with it, a final message from humanity itself. The golden record. Attached to Voyager's side, there is a small golden disc. A message. Not for NASA, not for scientists, but for whoever, or whatever, might one day find the spacecraft drifting through the galaxy. It's called the golden record. A 12-inch gold-plated phonograph designed to survive deep space for potentially billions of years. And in many ways, it may become the last surviving evidence humanity ever existed. Carl Sagan and his team assembled the record in 1977, and what they chose to include says something extraordinary about humanity. The sounds of ocean waves, thunder, wind, birds singing, human laughter, a kiss, music from different cultures around the world, greetings spoken in dozens of languages, even brainwave recordings from a human being in love. Because the golden record was never really about aliens. Not entirely. It was about us. Humanity trying to preserve a small piece of itself against the immensity of time. A species looking out at the universe and saying, "We were here. We existed." This is what we sounded like. And the terrifying thing is, Voyager may outlive Earth itself. Long after human civilization disappears, long after cities collapse, long after every building, every monument, every digital archive on Earth is erased by time, Voyager will probably still be drifting through interstellar space, still carrying human voices through the darkness. In around 40,000 years, Voyager 1 will pass near another star, not close enough to stop, not close enough to be discovered easily, just silently moving through the galaxy forever. And unless something destroys it, the golden record could survive for hundreds of millions, possibly billions of years. Longer than human civilization has existed, longer than humanity itself may survive, which creates a strange possibility. One day,
Voyager may become the only remaining trace of our species, a silent machine drifting between stars, carrying fragments of a civilization that once looked up at the night sky and wondered if it was alone. And maybe that's why Voyager feels so emotional to people, because hidden beneath all the science, Voyager represents something deeply human, the need to reach beyond ourselves, to leave something behind, to believe that even in a universe this enormous, our existence mattered. But eventually, even Voyager's voice will disappear. And one day, for the first time in nearly half a century, humanity will stop hearing from the farthest object it has ever created.
Right now, Voyager 1 is still alive, still moving through interstellar space at nearly 38,000 miles per hour, still sending signals back to Earth. But eventually, that signal will stop forever. Not because of an explosion, not because the spacecraft crashes into something, but because Voyager is slowly running out of power. Year by year, its nuclear battery weakens. A few watts disappear, then a few more. And somewhere inside the spacecraft, another system shuts down permanently. At NASA's Jet Propulsion Laboratory, engineers are now making impossible decisions. Which instrument survives a little longer? Which system gets turned off next? Which part of Voyager's voice goes silent forever? Because the spacecraft no longer has enough energy to run everything, and once something is shut down, it will probably never come back on again. One day, the final instrument will fail. The last scientific data will arrive. The last readable transmission will cross billions of kilometers of darkness and reach Earth. And somewhere inside a control room in California, a screen that has been receiving signals for nearly half a century will suddenly stop. No more telemetry, no more engineering data, no more heartbeat, just silence. And what makes that moment so emotional is that Voyager has been talking to humanity for almost 50 years. Entire generations have lived their whole lives knowing this tiny machine was still out there, still exploring, still surviving. The spacecraft launched before most modern technology even existed, and somehow outlived much of the world that created it. But even after the transmissions end, Voyager's journey will continue. The spacecraft will keep drifting through the Milky Way for millions of years. Cold, silent, dark, passing distant stars humanity will probably never reach. And attached to its side, the golden record will still remain. Human music, human voices, fragments of Earth, a message carried endlessly through the universe. Maybe that's the strangest part of the entire story. Voyager was originally built to explore planets, but in the end, it became something far more important, a monument to human curiosity itself. Proof that on one tiny world, a species once looked out at the darkness between stars and decided to send part of itself into it. And long after humanity disappears, Voyager may still exist, drifting silently through interstellar space, carrying the final whisper of a civilization that once reached for the stars.